Lesson 4.5 is all about scatter plots, and the reason this ties in so well into our unit of writing equations is because once we define and review scatter plots in general, we're going to then really focus on writing lines of best fit, finding a line of best fit that lets us see a pattern and make some predictions based on the data. So let's first define a scatter plot. So a scatter plot is a graph that shows a relationship between two data sets. So a scatter plot, okay, is a graph that shows a relationship between the two data sets. The two data sets are graphed as ordered pairs on a coordinate plane, and you have a couple of examples here to see. Scatter plots can show trends in data, okay? So oftentimes the big difference here is that instead of us starting with an equation like we have over the last couple of weeks, where we have an equation and then if we needed to we could create a table of input output values and graph them, and every one of those points was on that along that line. This is more like real life data. It might be what you would do in your science class or in a statistics class, where you've collected data, not from an equation. You don't have an equation yet. It's real life data, and you've collected it and you're making a plot to see if there is a pattern, to see does this fit more or less a straight line. So it's real life data, and it's not generated by a function rule, okay? So let's take an example really quickly, just reviewing how to read a scatter plot. So for this one here, the scatter plot below, or the scatter plot here, shows the amount in grams of sugar versus the number of calories for 10 different smoothies. So they compared how much sugar it has to how many calories, and they did that for 10 smoothies. Okay, so if they say, well, how many calories are in the smoothie that contained 56 grams of sugar, it's just a matter of, kind of lining up an ordered pair. So we're going to look for the smoothie that had 56 grams of sugar. Well, 56 sugars along the x-axis. Here's 56. If we go up to see if we can find a point, we find this guy right here, and then we can look across to the y-axis and see how many calories that particular smoothie had. So the smoothie that had 56 grams of sugar had 270 calories. Okay. How many grams of sugar are there in a smoothie that contains 320 calories? So we're going to go kind of the same task, but the other way around. So now we know the number of calories. So we're like, okay, what if this smoothie had 320 calories? Do we have any data points, any smoothies that met that criteria? We do right here. So then we look down here to find out how many grams of sugar it had. For this one, it would be 70 grams of sugar. What tends to happen to the number of calories as the number of grams of sugar increases? So essentially, as we increase, we read this from left to right, right? As the sugar grams are increasing, in general, what is happening to the calories, right? So when I compare something over here with less grams, where the calories were around 250, 260, when I compare over here something with 70 grams, we're looking at 320. So I think we would all agree there's kind of an upward increasing pattern, right? So what tends to happen to the calories? The calories, they seem to be increasing as the number of grams of sugar increases, right? So we could say the calories also increase. Now, is it a perfectly hard and fast rule? Could we write an exact equation? No, right? There's definitely some leeways. There's probably some other things that come into play as far as calorie intake, but there definitely seems to be a trend, right? That as the sugar increases, so did the number of calories. Okay, let's try one more. This is all about the weight of a baby. So number 2 says the scatter plot shows the weight in pounds of a baby over time. It says, what is the weight of the baby when the baby is 4 months old? So this is age in months. So when I see the 4, that's 4 months right there. Okay, and again, we're just practicing reading this. If you want to pause it and try it on your own, then you can unpause the video. If we look for age in 4 months right here, and look to see if we have a data point collected for that. Here it is. And then we can go across and read how many pounds this baby was. It was 14 pounds. What is the age of the baby when the baby weighs 17.2 pounds? That's really specific. Okay, so same activity, but we're looking now starting with a value for pounds and looking for an age. So we're going to go to the weight axis. We're going to look for 17.2, which is probably right between 16 and 18 or just slightly off. And we're going to see if we have a data point along that value. There it is. So this guy looks like it fits the bill. And then we'll come down here and see how old that baby was. It was 8 months old. Okay. What tends to happen to the weight of the baby as the age increases, right? So is there a pattern here? As the age increased, you know, as the baby got older, did we see a trend or a pattern here in the weight? Well, I think we'd all agree again that it is increasing also. So as the age of the baby increased, and that's how we'll always read these graphs from left to right, okay? As the age of the baby increased, the weight also seemed to increase as well. So the weight also increases. Okay. So what we are describing there when we say, you know, when I see that this increases, this side also seems to increase. This one's a little bit more straight, you know, it's a little tighter. The data points are a little bit tighter than this one, but they both had an increasing pattern. What we actually call that is, we call that a correlation. So what we were looking for in those last two questions, in both of those, is whether or not we were noticing a correlation. That's the official word for that. Okay, so a correlation is a relationship between data sets. You can use a scatter plot to describe correlations between data. So this is similar to the two examples we just saw. Okay, we consider a correlation to be a positive correlation if you notice that as X increases in your points, Y also increases. Okay. We consider it to be a negative correlation if, when you look at the data, as X increases, again, we always read this from left to right, we're looking at the X going from low to high, right? So from left to right, these points seem to be falling. So as X increases, Y decreases. That's considered a negative correlation. And then there's some data that just simply have no correlation. Okay, you know, if I try to establish an upward pattern or a downward pattern, I'm not really able to do that with any certainty here. The points just seem to be scattered up and down all the way across, more in a horizontal, you know, or a really spread wide out, widespread situation. Basically, if the patterns just show no, the points show no pattern, upward or downward, then we consider that to be no correlation. And that happens a lot too. So sometimes that's why we make the scatter plot, to find out, is there a correlation? Is there some sort of relationship, right? Sometimes we run experiments and we find out, oh yeah, there's really nothing connecting these two data points, right? Then you would see no correlation in the data. All right. So let's take a look at these graphs, right? Determine whether the data shows positive, negative, or no correlation. You can use this as a guide. If the patterns have an upward, if the points have an upward trend or pattern, it is positive. If they have a downward pattern, it is negative. And if you see no pattern at all, then it's no correlation. So let's try it. Okay. If you look at number 3, okay, as you go from left to right, and you can kind of just run your pencil. If I were connecting this, which direction would my pencil be going here? And I think we would all agree this is going upward, right? So as X was increasing, the Y's tended to increase, generally speaking, as well. So this would be a positive correlation. Okay, it's a positive correlation. Number 4, same thing. If I look from left to right, we're going to read from left to right as x increases, and if I just kind of run my pencil here, there's definitely some scatter plotting, right? It's not a straight line, but I definitely seem to be having a downward, right? A downward pattern here. So as x is increasing, the y values actually seem to be decreasing. That makes this a negative correlation. Okay. If you look at number 5, okay, again, we're going to read this from left to right, from low to high. I go from here to there, 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 to there. So I really seems to just be kind of fluctuating back and forth, scattered, more just going across, but no clear upward or downward pattern here. I would say this guy has no correlation. Okay, and if you want to pause it here and try number 6, look to see what kind of pattern you might recognize here. And just by looking at these points, actually the first few are actually very straight, and then you go up this way, and generally speaking from left to right, these points certainly seem to be increasing in their y values, so we're looking at a positive correlation here. So at this point you should be pretty warmed up on how to read and interpret a scatter plot.